Question number 22 says a cube is inscribed inside a sphere, and the sphere has a radius of 1 meter. And what's the surface area of the cube? So really what we want to do is find the side length s of the cube. And if we find s, or s squared in this case, we can find the surface area of one side and multiply that by 6 to get the total surface area. So what I've done is I've drawn the cube and then kind of outlined a sphere on the outside of it. And from the center of the sphere to one of the corners of the cube represents the radius. And that radius is equal to 1. So we need to use trig. So we're going to need to use a right angled triangle. So we need to identify our right angled triangles here. So I've drawn a right angled triangle in blue here. So from the center of the sphere down to the bottom. So imagine that this line here goes to the bottom of the cube. So this is on the bottom surface of the cube. So from down to here, that represents the middle of the cube down to the surface of that cube. So that's going to be, I'm going to call that s over 2. So that's going to be half of the side length of one of these edges. And I've written it over here, s over 2. And we're just going to call this length x. And that's going to be from, imagine the surface of the square on the bottom, that from the middle to the corner of the square, and we're just going to call that x. The other right angle triangle that we're going to use is we're going to take that x to that corner, to the middle of the square, and from the middle of that square, we're going to go to the other corner in green, and so that length is also going to be x. It's going to be the same length because that is going to split that square into 45 degrees. So I've got that on the right hand side here. I've got the side length s, which I'm looking for, and it's going to be this 45-degree triangle. So essentially we need to solve for x, and then we can use that to solve for s. We have a system of equations. So I'm going to write my two equations out, and I'm going to use Pythagoras for both of them. So I get 1 squared is equal to x squared plus the half side length squared, and that's going to be the blue triangle with that red hypotenuse. And so I'm just going to simplify this. I'm going to end up with x squared, sorry, I'm just going to make this x squared plus s squared over 4. So that's one of my relationships. And the other relationship is going to come from that other triangle here. So I'm going to end up with s squared is equal to 2x squared. So I get x squared plus x squared, or 2x squared. Okay, so that's my other relationship. And so I'm just going to solve for s squared and say that that is 2x squared. Or in other words, I'm just going to say that x squared is equal to s squared over 2. So this is a system of equations. I'm going to solve for s squared because s squared actually gives me the area of one of the sides. So I don't really need to solve for s if I know what s squared is. I'm going to substitute the x squared in this equation. This now becomes s squared over 2 plus s squared over 4. And then I can just solve for the s squared. So I get 1 is equal to, this is going to be 2/4 plus 1/4, which is 3 over 4 s squared. And that then allows me to solve for side squared, which is the area of one of the squares. And that's going to be equal to 4 divided by 3. So if 1s squared is equal to 4 over 3, then the surface area is going to be 6 of those surfaces, which is 4 over 3 times 6, or 24 over 3, and that's going to be 8 meters squared. Okay, so this is the answer to that question. Now in the textbook the answer is given as 12 meters squared, but the answer is actually wrong because of the way they solved it. And so what they did to get the 12 meters squared is they just drew a circle and they inscribed a square inside that circle, and what they said was that the radius was this length from the center of the square to the edge of the square. the corner of the square. And they said that's going to be the radius. Well, that's not true, because to do that we need to have a flat surface to look at. So imagine slicing the sphere so that it exposes just the square where it touches the corners. Well, if we do that, we actually have a circle. That circle that it's inscribed in is smaller than the actual surface of the sphere. Because imagine there's actually, I kind of draw it outlined in blue here in dots. That would represent the actual outside of the sphere. So if I took a slice through the middle, I would get this blue dotted line outline, and that outline is actually bigger than the cube that fits inside that square. So we couldn't actually slice through the middle of the sphere and actually get it to touch the edges. It touches the edges. These corners here touch the edge of the sphere, not through the center of the sphere, but kind of offset from the center, which means that the circle that we inscribe that square in is not as big as the circle that is in the middle of the sphere. Okay, so this length here is not really the radius. The radius really is a bit bigger out here. So the real radius is this line here. Okay, and that's going to be longer than the radius that they use. They said that this line in the square, that line there, is the radius, which is untrue. Okay, and that's why their solution of 12 meters squared is actually wrong.